Okay, so in the previous video, we looked at the initial setup for most questions. And we're just going to start and we're going to go through now and we're going to answer a few of these. So let's get into it. So a particle was projected from point O on a horizontal plane with the speed 28. We broke that up. The angle, we used the angle to help break it up. The particle moves freely under gravity. That just means, you know, we use A is 9.8 or minus 9.8. And now we're going to do the greatest height, okay? So first one here we're going to do is the greatest height. So if you want to find the greatest height, we need to think about the part of the journey where that applies. So that's this point here, okay? And we know something about this point. Now I'm going to change the color because I'm talking about this particular point. So I need to make sure that all my information here is also about this particular point. So at this particular point, what we're going to do is we're going to say that vertically, it goes from, if up is the positive direction, it goes from a very small positive number, and then eventually it starts going down. It'd be a negative number. So there must be 0 in between, okay? So 0 is the greatest height. Greatest height means use v is equal to 0. And yeah, we're just supposed to find the height. So we're supposed to find the S value then that goes with this. S, remember, means the difference, if you like, of where you are at the end of the journey to the start of the journey. So we've got our 4 things here. We've got 3 numbers. This means a SUVAT can be used. Which one will we use? Well, there's 2 ways you could do this. You can think of the ones that have those letters, or another way you can try is you can think about which SUVAT doesn't have this letter. So let's try that approach. So v squared equals u squared plus 2as is the one that doesn't have a t in it. So if we do that one there, 0 equals, very common, 0 equals, so that's a greatest height question. 28 sine 30 is actually a nice number. It's 14. So it's 14 squared plus 2 and then minus 9.8. In the previous video, if you haven't watched that one already, we talked about how the sign is almost as important as the number itself. So please make sure you're happy with that idea. S's, I like to write S's in a very obvious way because sometimes they look like 5s. So that's how I'm going to write my S. If you work this through, you get S equals 10 meters, okay? So the fact that it's positive tells you that the difference from the start of the journey to this point here is 10 meters in the positive direction. So it's 10 meters above you. So that's it. That's all we need to do for that. That's the same as the answer. So 10 meters. Right, what's next? The time of flight of P. Okay, so first thing we want to do is we want to think about which part of the journey are we describing, because if it's the same part, we can recycle all of the numbers, but if it's not, we can usually only recycle the U and the A values. So the time of flight of P refers to when it's here, which is a different point. So I can't really use any of these numbers that I've just done. So I'm going to get rid of those now because they're not valid anymore. So what do we know about this part of the journey? Is it about being horizontal or vertical? Well, horizontal, we don't have any information, so that's not very useful. But vertically, we can write down S equals 0. So the meaning of this statement here, S equals 0, is if you look at the start and then if you look at the end of the journey, the sort of how high up the particle is hasn't changed. Because what S cannot do is it doesn't think about what's happened in between. That's not how it works. It's the displacement. It's just sort of like before and after. So at the start, we are this height. At the end, we are this height. So that's why we use S as 0. Okay? So S as 0 is the key number there. And then it says the time of flight. So that's going to be the 4th thing. So I've got my 4 bits of information, 3 numbers, 1 unknown. So that means I should be able to find it out. What suvet doesn't have v in it? So it's ut plus half at squared. So you end up using this one a lot of the time for projectiles. Put your numbers in. So we get 0 equals, and it's all about vertical still, yeah? So I'm using the vertical. I haven't used this at all, notice. So 0 equals 14t plus half minus 9.8 t squared. So this ends up being a quadratic, and you should get the values t equals 0. So you can factor t out at the start. That's why t equals 0 is one of the answers. Or it rounds to 2.9. So why are you getting two answers here? Well, it makes a lot of sense if you think about it. You've said, where is the difference sort of 0? Well, at the start, the difference will be 0 because that's where it started from. Okay, but we clearly don't want that. We want the value at the end. So we're going to use s equals 0 when things hit the ground, from the ground, and 2.9 is the number there. And finally, the distance OA. So we want to scan the question. We know that this is O. This must be A. So OA must refer to a horizontal distance. So really, this is OA. Okay? And is it the same journey as the one before? If it is, we can recycle stuff. If not, no. Yes, it is, because it's about hitting the ground. So this 2.9, which we just found at the end, that 2.9 can also be used here. Okay, so now you've got distance equals speed times time. So 28 cos 30, which is not as nice of a number, times 2.9 is actually more like 2.857 ... So maybe you keep that stored in your calculator. It ends up being approximately 69 meters. Okay, so you've just seen really, I would say, the two most common questions, which is a greatest height question, the secret is v equals 0, and hitting the floor, from the floor, s equals 0. Right, let's speed up a little bit. We're going to have a go at this one here. So last time, this was a vector one, so we had the numbers already. We didn't have to resolve. We didn't have to break anything up. The question is, find the initial speed. Well, the initial speed is actually that one. It's the one that we normally get given. So we just want to do, for part A, we'll just do some Pythagoras. So 3 squared, 5 squared, and square root it. Okay, which ends up being root 34, or what's the decimal for that one there? I don't actually have the decimal. I'm going to leave it as root 34. And it says speed, so a good habit is to put units on. So root 34 meters per second. Angular projection just means this one here. Okay, alpha you normally see get used. So this is a right angle triangle because they're perpendicular I and J. So what you can do is you can just say tan of alpha is equal to opposite over adjacent, so that's 5/3. So if you do arctan, you get alpha is around 59 degrees. Okay, just a note about that. On the mechanics side, we tend to use degrees rather than radians. So that's why I'm going to leave it as degrees. Okay, got a few more questions, so let's just do a few more of these. I recommend at this point that you pause the video, have a go for yourself before we go through this one, and then we're going to do a slightly different one here. So last time we broke it up, 35 cos 30, 35 sine 30. Right, what are we doing? So particle moves freely and go. Find the length of time for which the particle is 15 meters or more above O. So this is a vertical thing, isn't it? Because it's saying above. So if we start at O, 15 is an important number. What else do we have here? Time. So time's involved in the question. So I think we're working with this again. So no surprises. We're going to do s equals ut plus half at squared. And when we do this one, we're going to say then that it's 15 equals 35 sine 30 is 17.5 exactly. Okay, so 17.5 t minus 4.9 t squared. So you will see minus 4.9 a lot in these kind of questions. If we get the 0 on the other side, So let's do 4.9 t squared minus 17.5t plus 15 equals 0. We get two t values. So the t values are 10 over 7 and 15 over 7. So what do these numbers actually represent? They represent when the particle is, because up is my positive direction, they represent when the particle is 15 above. Why are there two answers? Well, there's two answers because it will be something like that. One will be up on the way up, one will be on the way down. You know, the lower number is going to be on the way up then, isn't it? That's going to be on the way down. So it said the length of time for which it's 15 meters or more. Well, that's going to be the difference between these then. So the answer is 5 over 7 seconds. Okay, which is about 0.71. Right, next question. So let's have a go at this one. Let's just move it slightly out of the way. Yeah. So I'm going to do something a bit different on this one. So first thing I'm going to do is I'm going to, and you might have seen this in the previous chapter, first thing I'm going to do is I'm going to take this tan theta equals, and I'm going to just draw this one here. So tan theta equals 4 over 3. So the opposite side's a 4, this is a 3. You might remember doing this in the previous chapter, that you often sort of found this one out and used sine and cos and so on. So that's likely what's going to happen here. One thing that sometimes people get confused about, this is completely separate to the diagram of the projectile, okay? I'm just drawing this out to help me get this number, really, and to help me pick the right values if sine and cos comes up later, okay? So this is not about the projectile, this is just sort of an aid to help me out in this question. So now I'm going to actually kind of sketch it and try answering it. So we haven't done any work on this one before, so we're going to do this one from scratch. So a particle is projected from point O with speed v. There's the angle, and yeah, we just wrote some stuff down about that. And I like to just kind of draw the projectile, something like that. So the point O is 42.5 above a horizontal plane. So what we need to be doing here is just thinking about our diagram and if it needs to be changed at all. So I've drawn it sort of starting from the floor and going to the floor, which is the most common scenario, but it's said that actually this is above, so I need to change my sketch. The sketch is not correct, so that's fine. That's why we read it carefully and we try and sort of think about what we're doing and if it all matches up. So I think we've got ourselves like a platform question. So I think we've got something like this. So this here is the launch, so that's V, and that's theta. This is a platform then, and then this is the ground, is sort of the idea. So let's just read it again and check it makes sense now. So the particle is projected from point O at an angle, yeah. This point is 42.5 above the plane, yeah. I could even write 42.5 there, I suppose. So 42.5 meters. The particle strikes the plane. Right, well, that's the plane then, isn't it? At point A. So I think this is point A. And then I've got some information. Okay, so now we're going to go to our sort of common steps. So I'm going to define the positive direction as up. I'm going to write DST, and I'm going to write SUBAT. And let's start trying to put some information into this one then. So what's the easiest one to do? Right, well, I can do a minus 9.8 there. So let's make sure that's minus 9.8. I'm going to get my U, my speed, my initial velocity, my speed, and my A values first, always. So the initial is V. Okay, so this is definitely a tricky question. Oh yeah, because look, I'm trying to actually find out that V is 20. So I'm going to have to problem solve this a little bit before. Tricky. Okay, so I think I'm going to just use the information about the point then, because if I can't see what to do, well, this is useful information. So I think I'm going to have some information that goes in the vertical one. I think that's the way it's going to go. So let's use the vertical S. What should S be then? So it's 42.5 meters above the ground. Well, then this actually needs to be minus 42.5, okay? Because it's against my direction. So S and A are both fighting. So they're sort of in the opposite direction, going the opposite way, or wanting to go the opposite way to my direction. So those are all negative values. U, I would quite like the U to be included in the question because I need a way of working this out, right? So I'm going to just call that U for now. And I need another piece of information that goes with this. So I've got the minus 42.5. Do I know anything else about it? Yes, I know that a t value of 5 goes with that as well. So this should now be enough information. Which one am I going to write out? Well, it's S equals ut plus half at squared again. So I'm going to write minus 42.5 equals 5u minus, let's just have a think about this. Is this, yeah, so minus 4.9 times 5 squared, which is, 25. If you kind of do some work with this one here, actually, I'm going to, just to match the working out from the slides, I'm going to just change what I'm doing slightly, okay? You could do this, by the way, and this will work, and this is absolutely fine. But just to match the working out, I'm going to do something a little bit different, which you also might see. So notice here, I wrote u as u, right? So this is one approach, and you can do this, and then you'll have to think about the triangle afterwards. So that's one way that you could do it, but a different way of doing it would be the following. So if I use this triangle at the start, I can do sine theta equals 4/5, right? And cos theta equals 3/5. Well, why is that useful? It's useful because if this thing at the start is called v, yeah, I can break it up even though I don't yet know what it is. So instead of writing this as u, I could write this as v sine theta. Yeah, because it's the vertical bit is v sine theta. And then look, I know that v sine theta is 4/5, so I could swap that bit out. So either approach is fine, but I'm going to go with what's in the slides just to make it slightly less confusing. So I'm going to write that as 4/5, and I'm going to write v, and the only reason I'm writing v is because that's what's in the question, even though that is a little bit confusing. Okay, so if I do it that way, instead of using u, because that's the bit that I've just changed, I'm going to write it now as 4/5. Okay, 4/5 v. So let me just change that. So 4/5 v. And if you do that, it means that when you get v, when you solve this for v, you go straight to the answer, which will be 20. Okay, so from here you just need to simplify that. Some bits actually even cancel. Just see that bit cancels there. You should end up getting a final value of v. And that's really, really good because, as we said before, when you find sort of the initial, you can just keep reusing that value again and again and again. So that's going to help us answer the final bit. And even if in the real thing we couldn't answer part A, we should still be able to answer part B. So I'm going to actually write that all again, because now that I know that, it's really, really useful. So this was, V was 20, so this should be 20 sine theta, okay? And when you do that, because it's 4/5, you'll end up getting, this one should be 4/5 of 20, which is what, 16. Okay, this one, the speed over here is 20 cos theta, which is 3/5 times 20. So 3/5 times 20, that should end up being 12. Okay, A, we write our A as minus 9.8. Okay, so what's the other question now? So this is O, this is A. They want the distance. Remember, distance means that they want the diagonal. Okay, so I know that, well, actually, look, I've got 42.5 already, so that's quite useful. I need to find the horizontal then, don't I? So before we found out that this was 5 seconds to there, so I can use that 5 seconds as well. So I know that it goes, the speed is 12, and I know that it's 5 seconds. Why do I know it's 5 seconds? Because it's the same point that was talked about in the first part of the question. So that means that this is 60. So for part B, I'm going to do 42.5 squared plus 60 squared. I'm going to square root it, and my answer for that is 74 meters. Okay, so that one is quite a lot more difficult because they didn't give us the initial. Okay, so what you have to do is you have to go off a point that you know other information about. You have to involve it in the question, whether you write it as u or whether you sort of use this stuff earlier to write it directly, like 4/5. We also, I think that's a useful one to talk about the idea that you can't just assume that it's always going to be ground to ground. In fact, it often won't be. So check that your diagram fits the question, and if it doesn't, you need to redraw it so that it does. So we're going to stop on that one there, and in the next video, we're going to try and answer this one that's got a few more sort of bits and pieces to it.